Hello, check. All right. Welcome in. I'm just getting set up here. Trying to improve my audio. I noticed a little bit of a problem when I was reviewing the stream from last week. See if I can address some of the filtering that I've got going on my microphone here. It seemed to be a little bit aggressive. Perhaps it'll be a little bit better today. I have a noise gate set up in order to kind of reject some of the noise that's going around in the room, but it seemed to be a little bit too aggressive and it was cutting me off. So we'll give this a try. Hopefully we're improved. Okay. Founder, what's going on? Alex, what's up? Do I have Discord connected? No, Discord not connected yet. Okay. Discord. See if I can get this up and running here so I can see all the Discord chat as well. Okay. Stick with me 1 second. Get this straightened out here. Okay. That's that. Now, Fender, you're over in Discord. Here. Channel ID for Discord. Alright. Where do we find our channel ID for Discord? Channel name. Channel settings. Server settings. Where's Marty when we need him? Marty, you in here yet? I don't remember where I found that setting. Looking in Buffalo multi-rotors here. Somewhere here. Stream key? No? Hmm. Alright. I'm gonna have to text Marty. Unless I can see you there, Fender. Nope, you're still right there. Oh, and I get started with this X-Class racer and this urethane casting here. So what am I missing from last time that I'm doing wrong here? I think I've seen every menu here. Hmm. Okay, well, forget it. That is taking too much time. Channel ID is part of the URL. Does that help me out? Where do I find the URL? Is there like a share link for this or something? Uh, okay. Thank you, Fender. Is it the first one or the second one? Last numeric sequence. Okay. Copy that, paste it over here. Okay. Connect. No, not happy yet. How about now? Almost. Looks like it's thinking harder. There we go. Thanks, Fender. Thanks for that little link. Okay, I can get rid of that window. This window. And pull up my broadcaster. Okay. Why are we preparing again? Keys in the keyboard. Okay. Desktop. SolidWorks. Okay. Oh. There we go. Hi and welcome to Design and Build, finally. After, what, 9 episodes or so that I'd have that figured out by now, but I guess not. Anyway, what are we up to? Where's my thing? Okay. I was able to 3D print our battery strap thingamabob for the top of our King of Hearts frame. Yeah, let's see if I can pull it up there. Oh, that's close. Too big in the microphone. Anyways, there she is. A little TPU job right there. And I was able to get this done without any support material, which is super fun because, whoa, pulling all that support material out of this guy would have been a terrible, terrible thing, especially with this hollow cavity in here and how sticky the TPU is. I don't think that stuff would ever come out of the inside of there. So I was searching for an angle to get this thing to sit on the print bed so that it wouldn't generate any support material and still print successfully. And what worked out really good is that we put that like big chamfer on the front edge right there. And that let me put it on the 3D printer right there. And that was perfect because it was able to grow this part without any support material. It was a huge help. A big win for me there. Works. So yeah, we'd cut that front edge of the part here. Kind of like a little aerodynamic thing. That camera to focus again. Anyways, so yeah, because that's cut at a 45-degree angle, I was able to stick that to the print bed just like that. And the printer was able to build that without any support material underneath it. Because the TPU doesn't have any problem doing like a 45-degree angle on your wall. And so it walked right up that part and did all these overhangs with really no struggle. I'm going to pull up on the, you can see on the webcam kind of where the worst spot would be. Focus this. Yeah, so right on the top of the heart is where you have the biggest overhang there, and it's not super well defined right there at the top of the heart, but I think that was just kind of a small price to pay for not having to use support anywhere else on this thing. The rest of it, all the printing came out good. I don't know if we can see the inside of here, but didn't have to generate support in there, and it is nice and clean in there, so our receiver should shove right in there. And the standoffs are in good shape as well. There's no support material to peel off of these. I guess you can see a little bit of like sagging right here. You can see how small this part is. Like there's the tip of my ballpoint pen. There's like a little bit of sag right there on the standoff, and that's normally where it would have put the support material, but I don't know. I think we're pretty good. So anyways, that's another part done for our King of Hearts frame. We got that here. So we've got our camera mount. Focus down here. We've got our camera mount, and now we have our little battery strap doohickey there. There we go. I think next thing up today, I want to cast those corners. And so we'll walk through that whole entire process right on a live stream here. So I went into my storage here and grabbed some resin. Got some smooth on onyx here. Nope. This is just straight black urethane. And I figure we can try our first attempt with this stuff here. So this is onyx from Smooth Cast. It's pretty hard stuff, but it casts really quick. And it'll also clean our mold out. Like the first part of the mold is going to pull all the like junk and dirt that was on the tooling off of it. And so here's our tool. And boy, I wish we'd focus here. Where's our camera? Camera. See if I can get this thing to focus a little better back down here. The autofocus set up. Back down here. There we go. Okay. So there's my mold. I've already gone and I've taken this outside and put mold release on it. I didn't want to spray that in the house, so I stepped outside just a couple minutes ago before the stream started, and I was spraying mold release on the mold here. That was a little bit of this stuff here. He's release 200. Yeah, this would be one of the ones from Smooth On. I got another one that's in a white spray can. But anyways, it's basically like Vaseline in an aerosol can. And so puts down like a super fine mist. That way it doesn't, I don't find that it affects the surface finish on your part. Anyways, there's our mold. Let's I'm in a SolidWorks. We have to find out how much material we're gonna need. Of course, the scale's outside, isn't it? That's okay. I do have scale next to me here, although it's not as accurate as the one that I have outside. Okay, so here's our corner. This is what we're working on here. We're going to be casting these little corners here. That's our job right there. And we got 4 of them in our mold. And so let's take a look. I've already entered in that this is some sort of urethane. So I'm going to want to take a weight from this. 2 grams. 2 grams of material. And we've got 4 of them. So we've got to mix up 8 grams total. That sounds like that's going to be a little bit tough on our machine. But, on our scale, but, I don't know. We'll see if we make a mess. If we've got our mix wrong, it's not going to cure. And we'll have a sticky mess. So that'll be fun to do live. I can just put on some gloves here. Take a sip of my coffee. Grab a couple mixing cups. Whoa. Mixing cups there. Get rid of my gloves here. Okay, that's a dirty cup. There you go. Bottom of the stack. Okay, so I got to get 8 grams of material in here. Yeah, we got to stir this stuff up. So I was saying on a previous stream that you can't shake the urethane. The urethane has to be stirred. If you shake it, you'll induce bubbles into the mix, and they'll never come back out. You'll basically be left with urethane foam. And we're not pressure casting or vacuum casting or anything like that, so we got to make sure that we don't get too much air trapped into these things. Whoa. Boy, that cap's on there. Oh, yummy. Oh, it's black. That is going to make a mess if I get that on anything. Normally we would do this out in the barn in the shop, but I think we more fun doing this live rather than me pre-taping it. So let me cut the foil on these tops here. See what we got. That's good stuff there. I have to find a place to put all this stuff. Okay. What's that? There's part A. That's going to be the hardener. The hardener is typically that like amber colored liquid. And this black is our resin. Our formula here is written on the bottles, and I believe it's 120 1. Correct. Nope, good thing I checked. It's 1 to 1. 1 to 1. Oh no, it's that's right. It's 1 to 1 by volume. It's 120 to 100 by weight. So I need 120 parts of A to 100 parts B. So let's make that easy. We'll do a little bit of math here. We've got 8 grams that we need to cast, right? So 8 grams. We're going to want to go over by a good amount because there's going to be a couple grams that are going to stick to this cup. So, I don't know, let's just say, let's mix up 12 grams. Okay, so if we mix up 12 grams, we'll take 120 plus 100. That's 220, so let's divide this by 20. Okay, there's our equal parts, and then multiply it by 120. There. 6.5 grams of A. And if we back up here, 12 divided by 220, that times 100, and 5.45 grams of part B. I should write that down. Oh, I'm getting this stuff everywhere. We're just started. 6.5 to, let's call it 5.5. And that should give me my grams there. Okay. Boy, we're gonna need some serious cleaning to do here. Okay. Goes on a scale. Head over to my scale. All right, here we go. Part A. Let's grab a paper towel here. Okay, grams. Yeah, this scale's not going to have the resolution I'm looking for, so this might be a little rough. We might just want to mix way over. Okay, I blew right past it. So I've got 9 grams in there. So I figure I'll try to hit 7 or 8 with this black. Oh, you know what? Yeah, bad. I didn't even stir that. Let's try stirring this first. No one's yelling at me in the chat to get this thing stirred first. Yep, there's little chunkies on the bottom. Good thing I caught that. The hardener's probably going to be fine. This is going to be the one that settles out. Oh. Okay, there we go. Okay. Trying to hit 7. Nope, right past it, right to 9. Okay, I think that's kind of that's it for the sensitivity of that scale. It doesn't really start reading until you get a couple grams in there. So, this might be interesting. Let's see, if I add B to A, I'll have more left over in the cup. That should correct for that. Let's test that theory out. Okay, here we go. So, once I do this, we got like 2 minutes, and then that's it. This stuff's gonna kick. Well, it doesn't look like much resin. Hope hope we're right. We're gonna find out if we're short. I want every gram out of this cup here. It just does not look like a lot of resin. Of course, the scale could be way, way, way off. We're gonna find out. This might have to spend a couple days in Smarky's hot box. Alright, here we go. Start mixing this up. Trying not to put too much air into it. And kind of scraping off the walls. Scraping off the bottom. And it's kicking. And I know that because I can feel the heat in my hand. So this type of urethane, it cures by giving off heat when the two parts come together. And oh, she's getting pretty toasty already. So something's gonna happen. Whether it cures all the way or not, I don't know, but at least I know a reaction is happening because of the heat that's coming off of this thing. Oh, it's actually pretty toasty there. Okay. That's that. Now let's see if I can get it inside of here without making too much of a mess. Here goes nothing. it is getting thick on me really quick. So it's not flowing very well down into the cracks because of how thick it is already. I think a smarter choice will be one of the thinner urethane resins that are available. That will help us out. Oh yeah, she's kicking. It is just about done. That's gonna be it. The onyx is too thick for the thin walled stuff. My judgment here. That was enough material though. Let's see if I can kind of get it to flow down into those cracks by opening the mold up a little bit. But I don't think it's gonna fill out. Nope. Okay. So we're gonna have to choose one of the urethanes that has a thinner viscosity when it's mixed. So this is nice because of how fast it is. It is. Hey, it already kicked. Not coming out of there anymore. So it's no joke when it's when they say it's fast. It is fast. That's dry. Dried too fast. So it didn't flow down into all the cracks because of how thick it was when it was mixed. So I think we'll wait for that to cure. Bring that up. So I can see that it hasn't flowed all the way out. So I'm thinking I'm going to drop down to the same resin that we're using for the raggy canopies. Because that has really good flow. It's got one of the lowest viscosities of the flexible urethanes. And so it should get down into the real thin walls that are on this part. I mean, it's almost there. They don't look too bad, but I can see that they're not. It's not all the way down into the cracks. So once that sets up and we pop one out, we can take a look at it. I'm just gonna set this off to the side. Let that fully harden up. And I think I'll choose one of the other urethanes. We'll go to something with a lower, much lower viscosity. Okay, bring up our page here. So, Smooth On's website here, and down to the urethane resins. And let's take a look at our smooth cast series. Okay. That was Onyx Fast that I just cast. And if we look at our specs here, get it on the screen for you where you guys can see it. So, yeah. Mixed viscosity 100. Well, that wasn't 100. That was definitely thicker than that. Hot life 2.5 minutes. Okay. I probably spent too much time stirring it and should have got it in the mold faster than I did. Because 100 is very thin. And that was definitely not 100. It was not flowing. It was curing. And that could also be because my mix ratio was pretty bad without my better scale, because that's out in the shop. If I were to switch to something slower and still thin, like let's say 45D, this is still very thin at 250 centipoise. I think that's what that's called. That's still very thin. And there, we've got a 5-minute working time. So that'll give me a little bit more time to stir it and get it in the mold before it starts hardening. So maybe that's what I'll do. Maybe I'll go out, grab some of that, and we'll cast the next ones out of this. Smooth cast 45D. So anyways, in about, I don't know, 15 minutes to a half hour, we can pop those little guys out of there and take a look at them. Go. Okay, not too bad, not too bad. Like I said, we got that part printed. Do I have Cura on this machine? No. Anyways, so like I was saying earlier, I wanted to print this little guy, which is our housing for the receiver, and it also locates the battery strap across the top, and it's all TPU, so it's flexible. It's the kind of the top standoffs for our electronics stack as well. And I wanted to print that out with support material, no support material. And if I would have printed it like this on the bed, there would have been support material inside of our receiver cavity. There would be support material all over the underside of this thing. If I would have printed it stood up like this, there still would be support material in order to support the roof inside of there. And there'd be support material under each one of the standoffs. Support material under these two faces. So anyways, I found that I was able to print that successfully on that chamfered face right there. So it grew on the bed like this, and that 45-degree angle was perfect for getting through this whole part without the need for any support on it. And it's like three walls thick, and then it has the cubic subdivision inside. Havelock, you put some of that epoxy glaze on your poker table. Yeah, once it goes, that's it. There's no stopping it. And the bigger your batch that you mix up, the faster it kicks, because the bigger batches generate more heat. So I'm poking the part, poking these things sitting next to me, and they're hard. They're probably just about ready to come out. Let's load up our next little project. Oh, just a little update on our Delta 5 enclosure. That's kind of what we're looking at there. I got the Raspberry Pi sitting in there like that. Our two Delta 5 boards. The nanos that run across there in our aluminum enclosure. And right here is our Ethernet port, and she's waterproof. That'll supply power over Ethernet to fire this whole thing up as well. And I have the bar stock on its way. So I got a bar, it's 1.5 by 5, 1.5 by 5, and I think it's like a 72-inch bar. And so I went in and adjusted some of the dimensions in order to make that machinable out of that bar. So before, I had this drawn as 12 inches by 5 inches, which means that we wouldn't be able to machine the outside of this box, and we'd be left with the like extrusion marks from the bar. So I brought these numbers in. So I brought this into 4.9 inches and 11.8 inches. That'll give me 50 thousandths of material that I can peel off around the perimeter in order to give myself a really nice machine finish on this part. Same thing in the height. The height is now 1.4, right? So 1.4 inches in the height. Again, that's going to give me some material to remove off the top, and I can face the bottom and be left with a really nice surface down there. and I put this shoulder in here. The plan with that is I'll cut a polycarbonate window for the top of this thing, just like the immersion 8-way has like that polycarb cover. Might be acrylic, but anyways, I'll probably stick a piece of polycarb on this. And we've got our like little M3 screws about every inch or so to screw that thing down into. And our little 6mm standoffs for our Raspberry Pi. And then we'll just use some like thermal transfer tape, some double-sided tape and whatnot to secure those Delta 5 boards down, because those Delta 5 boards don't have any mounting holes in them. Yeah, so that's what we have to do there. I do have to remove a little bit of material when we set up and drill this hole here, since I kind of made the box a little bit more compact in order to fit in that bar. Like if I went up to the next size up bar, it would have been a lot more expensive. It's just so much more material to add like an extra inch to get like a 6-inch wide bar or a 2-inch deep bar. Lot of extra money. So anyways, I did what I could do to fit everything into that bar. And so when this operation gets set up, I'm just gonna have to get down. It's like I don't know, 1 1/8 inches. That we're gonna have to reach down in there and clear that out against the floor. I have a thick floor on this guy. I've got a thick floor and thick walls here. And the reason behind that is I want to put some blind 1/4-20 holes on this guy so that it can be mounted in unusual locations. That seems to be that's my only complaint with the immersion timer, is that you're kind of limited to how you can mount it, because it's completely smooth. There's nothing on it, to attach to, right? You can't get clamps on it, you can't get screws into it, like there's nothing, right? It's totally smooth. And so at least on this one, I want to be able to mount this thing on a light stand or a C-stand, or screw it to a gate, whatever, anything. The holes will be blind though, so that we're not letting water get inside of this thing. And but it should be enough material to get some blind holes in there. They won't be fun to machine, but I don't know, they'd be fine. I think the other thing I want to do is in the corner where I have a little bit of extra room right here. Maybe I can do that real quick. Is that I want to have like a through hole in this thing for a light stand, so that you could possibly put a light stand in the corner of this box. Let's see. Just make this big enough to not interfere with that Raspberry Pi that's sitting there. So I'm going to give myself a little extra material to work with right there. All right. And we're going to throw our radiuses in these corners, because our tool that we're using is probably a 1/2-inch tool. So that's all we're going to get there. And we're going to break that edge so that there's nothing sharp there. We've got an Ethernet wire turned in the corner right there, so we don't want that thing sharp. And now that I have some extra material there, let's double check to see if we're hitting the Raspberry Pi. Nope, we're not hitting the Raspberry Pi. We still have room. Looks like I have to move those standoffs. But now, hopefully what I can do is come up from the bottom and put a hole for a light stand, so that anybody that owns a light stand can get this thing mounted. And I believe that's a 5/8 inch hole. Can I fit a 5/8 inch thing there? Yes, I can. Okay, so that'd be like that. And we'll kind of dimension it to there. There we go. And we want to come all the way up, but not quite through. So we'll offset from this surface up to surface. No, offset from surface. And just like stop basically like 1/8 of an inch short. Where's my cut? Holy cow. Offset from that surface. 0.1. Find the end face. Interesting. Do it the old-fashioned way and type a number in. Oh, fail on that. All right. Well, anyways. Okay. So there's our little hole. We throw a little chamfer on there. Make it nice and easy. Just stick that thing on a light stand. Cool. There we go. That's out of the way. Of course, did I have any? Yep. We're not adding an extra operation in there or an extra setup in there because in the CNC, we are going to do the top face like so. I'm going to hog all the material out of there, drill all the holes, put the shoulder in there, chamfer on there. Then we have to turn it and we have to put our holes in the side for the Ethernet. And we have to turn it again one more time in order to face this off and put the chamfer on it. So we're not adding an extra setup because when we face this off, we can also drill that hole. So same number of operations. We're not really adding too much cost or time to that part by adding that hole. Okay, Delta 5 enclosure. Gonna close that out for now. And let's pull up our fun toy. Yeah, there she is. Now we're talking. X-Class buddies. And what did I dig out from the barn? Some supplies from 2014, right? There we go. I got a whole set of these. Perfect. For our X-Class racer. Man, they seem so big after playing around with little 2200 series motors for so long. This thing seems like a monster, but it's not. This was we threw these, basically threw these away because these weren't big enough for our heavy lifter. You know, they worked when we were flying around with the Canon 5D, but once we wanted to fly bigger cameras, bigger than that Canon, these motors weren't cutting it anymore. So they got trashed. And look at that. Back in 2014, what were we doing? We were braiding long ESC wires. For better or worse, we don't know. But I'm starting to see this again. I haven't seen it in a couple of years, and I'm seeing this on my Instagram every morning. People with braided wires on those quads. Don't know if it's a good thing or not. It's definitely a good thing if you have a long signal wire coming off your ESC or coming off your flight controller going to your ESC. So if you've got a long run from your flight controller to your ESC, that's probably the appropriate place to have a braided cable. Now, whether the motor wires should be braided or not, I've heard both cases where you should do it and where you should not do it. And I don't know which one's right. Yeah, Fender says I've not heard it's great electrically. Where's my little robot voice? Quest does it? That figures. Let's see. Oh, let's turn that up. Here, somebody chat with me again. Let me see if I can hear
Fender, I never noticed a difference.
There we go. I can hear you guys now. Fender never noticed a difference? Yeah. Something I heard where it's gonna like backfeed and kind of mess with the timing, right? Because these are sensorless drives, right? There's no like encoder or potentiometer running on this thing, so it's figuring out phase timing just by, I don't know, when the magnetic fields collapse. I don't know. Other people could tell you what is going on inside there better than I can, but something that the braid would maybe suppress that signal that it uses for timing a little bit. I don't know, but you're right. Like braiding this, like, I don't know, 16-inch wire. I don't know. It didn't really do anything.
_FPV.
Quest. We were just talking about braided wires back from 2014. My 16-inch run of ESC wire on our big guy that's in the trailer. These were the old motors that we took off of there because they didn't have enough oomph to pick up the big stuff.
Run on fixed timing, but you can set to auto ESC timing, so maybe the difference is there.
Yeah, that could be.
_FPV, look at that.
Yep. So, yeah, this was the motor we were flying around 5Ds with. Yeah, when we wanted to pick up the like red camera and stuff, we did it. So, I will show you. This is a Hobby King multi-star motor, and we put our faith in this motor to pick up a $30,000 red body. And it picked it up, but it made us very nervous because it did not pick it up very well. These are going to be 4014. Sorry, 4014s. 320 kV. That's what these are. So that kV may be a little low for what I was thinking. This probably would work on a larger prop than a 15. 320 is pretty low. Or we could go more than... No, I've got 6-cell batteries. So I want to use 6-cell. Keep this thing 6-cell. Right? 8-cell it is. Yeah, I guess we'll see. We'll see what happens. We throw 15s on this thing. And I don't know. I'd hate to buy more motors of this size. Just to screw around with. I have more though. I have
Havlock 716 $30,000.
I have spare motors from the old spreading wings, old DJI spreading wings. Those are similar size to this. But anyways, I think I've got 8 of these, which means I can build 2 X classes out of this parts bins. So we got old we got the ESCs to go with this. We got the motors. We've got flight controllers. I was discussing this with Mark. I'm tempted to use NASAs in these, right? Just use old NASAs. That way we'll have GPS and the NASAs can go into full manual. You could do flips and stuff with a NASA if it's in manual. But they're stable, and we know that they're stable on drones of this size. So I want to start there. I see too many people blowing up the quads right off the launch pad with the like Betaflight. Don't think it just wasn't made for it. I don't know why it would matter, but I guess the programming is just looking for faster movements than what these quads are doing. And the NASAs have the gyros soft mounted, kind of like some of the new flight controllers are doing now.
Work, I had one on my Hex.
Yeah, like a NASA.
Hits need to be turned down a lot from stock.
Yeah, yeah. I want to avoid the PID guessing game, and it seems like everything that we ever built with a NASA, we were able to just put the NASA in, and it flew. And you might tune it to get it to fly better, but at least the NASA would get whatever off the ground without much of a problem. And so that's what I'm hoping here, is that we can just enter the offsets in, and we'll be good to go. And at least we can get off the ground without like this thing doing a little backwards motor dance. So Quest says he has an extra NASA as well too, huh? Do you still have your NASA in your Hex? Maybe you should think about what we're doing here. This might be a perfect opportunity to put that thing back to work. Okay. Let's see. I'm going to pop these out here. Oh, they're grippy.
Quest_FPV nope.
Sold it? Oh, Quest, you stink. Oh, look at that. She came out. Yep. Like it didn't quite get down in there, but the texture on it is pretty cool.
That's what I run in my disco.
I can get that on the camera. There she is. There's our little booty, and it has a pretty cool texture on it, like it was like glass beaded or something. Or actually, this would be like, this kind of looks like Black Beauty sandblasting. It's a pretty coarse texture, but I like it. This not too bad. Like I said, it's a little thick, so it did not flow down into the
Azolite $65 new no.
Down into the corners.
$170 a year ago.
Nazalite 65 now. Yeah, right. That's crazy. Like I've got a new NASA in the box still. I figure that's what we'll throw in there. Focus this. There we go. So anyways, there's an air pocket right there where we didn't get our resin to flow down in. They said you could put these in a pressure chamber. That would blow those, it would collapse those bubbles. Bubble there. And it didn't flow into these corners either. Exposure on these little cameras is kind of tough. Yeah, so didn't flow down into this corner here or over here into that corner right there. So got a couple problems with it. I think a little bit thinner material or some faster stirring will work out just fine. And I guess the next thing would be that camera to focus again. Come on down. Let's see if it fits. There she is. Closer. Oh, that's our little protectors on there. Not too bad. Not too bad. All right. Oh, that'll be pretty cool. Yeah. Next batch will be perfect. Pop the rest of these out. Oh, they slide right out of there with that mold release on there. Yo. And cool. Perfect. I'm happy, even though our parts aren't perfect. Well, this one's not too bad. This one's just got one, where are we? This one just has one little spot in it, right there, that didn't fill. Yeah, like got an air bubble trap right there. But those thin corners, they ooh, everything's slippery now that I touched that mold release on there. So let's see, those two tips filled in just fine. Right there. But actually, yeah, I'm surprised that flowed. Oh no, there. Little cut out there. That's an air bubble. But that tip, this is kind of the hardest spot in the mold, is this tiny little tip there. And well, material got down in there. Actually, I would assume, right, that that's the hardest spot, but I'm looking at the parts and all of them have an air bubble right there. So that is really the hardest spot for that material to flow down into. Nice. I think we'll give this mold, we'll have to send it over to Smarky's Composites. Okay, chat. Where are we going on our big guy here? Back to it. Should we make this a legit X class, or should we just have fun and make this our own thing? And I say that because Mark was saying that 800 millimeter is the smallest that you can go with the X class, but I feel like I would love to bring the body in a little bit smaller until these ducts or nacelles or whatever they are, until they hit the body. To me, that would be the slickest looking thing, unless that ends up just being too hard to fabricate, right? Like right now, we can just make these as a separate part. We start blending that into the body, it might get complicated, but it's gonna look better. Sure will look better. Or we just make the ducts a lot bigger, still run the 15-inch props, but you'll have a nice big air gap between the tip and the duct so that it doesn't behave like a ducted fan. Because we're not using props that are designed for ducts, maybe it'd be better to get them away from the walls of that thing a little bit. Our motor mounts, I was thinking about running along this line. Even though it looks like this is less material and it's also closer to our body.
Quest_FPV, it needs to be close to the duct.
Yeah, I agree, Quest. Like if it's a ducted fan, it needs to be like, I think the smaller the gap, the better. That's certainly not how I want to do this. I would like it to have a comfortable margin there. I mean, we're not trying to do a ducted fan. We're just trying to make this thing a little bit less ridiculous, right? In case she gets out of hand. This body, let's see if I've got some 6-cell batteries. Throw on this guy.
Quest_FPV, I've seen some advanced airflow sims at work. I can show you some results.
Ooh, airflow sims. I like airflow sims. From what I read, the ducted fans are like self-stabilizing. They want to stay level, and so when you lean them over to get your forward motion, they're gonna fight you and try to level back out. It's like having a mechanical level mode, right? Analog level, mechanical level mode. But I think I don't know, just watching some of the old documentaries where like the military had that like tiny whoop that the guy was standing on. I think the problem with that thing was they could never get it going very fast because all it wanted to do was just self level. And that has to do with like once you get into the forward motion, the way the air like comes over the duct and stuff like that, it wants to like level back out. Where am I going? I'm paying attention. Into my drone folder. I'm looking for a 6-cell battery to throw on this thing. S. Go. There's our brick. Our nice 6-cell brick. 6-cell 8000. That seems like a lot of battery. What are these guys flying? Is that too much? Because I was picturing two of these. I was picturing one on each side. Right? So you'd have like one there and it would kind of be like flush to your body like that. That's what I was picturing. One on each side. But that's 16,000 mAh, and I feel like that's probably way too much and that they're not flying with that much battery. I mean, I was going to do two, but I suppose I could also throw it in this way, right? Stick it in sideways.
Quest underscore FPV inside or like a scoop where it's open in the back.
Yeah, like I was thinking just subtracting the
Fender, I don't
material.
remember offhand. On the demo I saw it was only one pack.
One pack. I feel like they're not running a ton, maybe 6,000 or so, maybe 8,000, but definitely a single pack, right? You gotta get 2 minutes out of it. That should fly that for more than 2 minutes. 8,000. I don't know. What are these? Let's look up these multi-stars and see what the specs are on these things.
Fender SIXS 5000. Those are pretty common heli packs that people would just have.
5,000s. I think we've got a couple 5,000s as well.
Havlock 716. How big is the drone? That's not a small battery.
Havlock, you missed out.
Of this design.
We last week, while you were gone, we decided to kind of poke around with some X-Class. So this would be an X-Class size drone, and for reference, that is a normal one. So there is our King of Hearts next to our X-Class. And we've collected some parts, and we might attempt to build this thing. Or build several of these things. I don't know yet, but I'm excited about
Fender
it.
Yet SIXS 5000 on the X-Class website. General Build Guides.
General Build Guy 5000.
Havlock 716 was home with the flu.
Okay.
No good.
Yep, that's no good, Havlock. I'm glad you're back, though.
Havlock 716. That's awesome.
6S 5000. So a brick more like that. That's a little bit more reasonable, yeah. Shove that into there. Hmm. It would kind of look cool with a through hole right down the center of it, right? That make that thing really ridiculous to fabricate. Probably, right? That probably would make that thing really tough to fabricate. Hmm. The dual battery idea allows me to keep this design balanced. We run 2 5s, you know, for safety. Get a 5 on there, 5 on there. And this is endurance X class, so the races are longer. That's what we say. Yeah, so you get one of those on each side. And then like you just Velcro strap right over the top of that thing. So like in here, right plane, we just have our cutout for our battery like that.
Havlock 716 NFL Draft next Thursday. I'm guessing I'm the only one of us that will be tuned into that.
Possible. All with some draft. The only draft I'm worried about is the draft on my walls here.
William Haw 3s on each side in pockets.
Ooh, yeah, right. Um, does that work? Right? Because you can plug them in one at a time,
Fender
even though
I'll
we're in series,
probably
right?
have it on, but NBA playoffs.
I like it. You're right. And then this could be a lot shallower. So our offset can be greater, like 5. Okay, let's just, I'm throwing values in there just to kind of get the idea. But then we got a pocket like that. And then jump back to our assembly. This guy can kind of live right in there and be strapped in, and it can get some airflow over the top of it, and it should be super easy to strap in, right? Throw that in a little pocket there and plug it right into like a bulkhead fitting, you know. And then internally it'll be wired in series so that when you put your 2 3 cells on the outside, you get your 6 cell battery.
716 Go Bills.
I like it. Good suggestion. Good suggestion from Lone Star there. Let's look up a battery for that. So, oh yeah. So, okay, here we are. Here's our old motor. Ooh, $50 a piece. Jeez. Oh, don't you guys miss the days of paying that much money for motors? That was fun back then. Let's see. Up to 8 cell. Look at that. Fender. We're in luck. I was looking at these windings and they looked kind of thin. But it says it's good for 8 cell. So we could do that. We could do 2 4 cells on the side now. So this is a 720 watt motor. Okay, so each one of these motors is a horsepower. So this drone's gonna have 4 horsepower when it's built.
Fender the crazy part was $50 for a 1806.
$50 for an 1806 is steep. But I remember paying a lot for a set of 1306T motors back in the day. That was my first FPV quad that I built. And I want to say that that was at least $100 kit for those things. Little 1306s. That's where it all started. That's the one that ripped my face off and sent me to the hospital too. Anyways, 26 amps, 720 watts, 8 cell max. I was looking to get an idea of how fast it would drain a 5,000 battery. Right, so you got 5 amps. 5 amps in an hour on that battery. And if you're yanking, I don't know, 15 off of each corner, it's gonna go pretty quick, right? Be 60 amps total when you're nailing it on a 5 ampere hour battery.
Fender really for
Yeah, you can get a couple.
4014, that's not bad. Bigger wing motors are about $45.
Yeah, it's not bad. The motors that replaced these motors were really expensive. We ended up with T motors on the big one instead of the multi-stars. That was a much wiser decision, I think. Anyways, yeah, so 5 amps. You want to do the math on that? A 5 ampere hour battery, and we're sucking 60 amps. What are we looking at for flight time? How do you do that? 60 divided by 5 would be a 12th of an hour, right? So 60 minutes divided by 12. 5 minutes? That'll work. That'll get us around the track.
Fender 5 minutes, but that's drawing to dead.
This is true. Right. Right, but that 5 minutes, 5 minutes of like high throttle. In our race, we shouldn't be doing 5 minutes of high throttle, so I think we're good. I think we have a set of motors and a set of batteries that should get us around the track. Just kind of looking at it real quick. Sticky urethane all over the place. Okay, so next I guess I want to look up a I'm gonna do this off screen in case I'm logged in. Choose my account. And are we logged in? No. We're safe. Okay. Batteries. I just want to look up. So we were saying 3 cell on each side. 3 or 4 cell. 5,000 on each side. Can you do capacity range? Uh-oh. Mini drone batteries. Where's the bigger batteries? 5,000. What do we got? Okay, tattoo. 4200s. That work, right? What's that? Electronics. Cool. Thanks for following. Yep. Waiting for stock. Tattoo. Maybe go right to Jen's. And take a look at the same thing over here. Lipo. Let's do a search for 5,000. Okay, what do we got in the 5,000 range? Nothing like the tattoos. A bunch of Gens Ace batteries. Oh, let's look up that 4200. Might work out. No, that's not what we want. Okay. How big do these tattoos go? Not big enough? Oh, 3,700 they go. That's not big enough, right? 5200.
Fender.
There we go. Stone blue batteries, 5200s. Okay, yep, that's it. Let's see if I can pull that up. Thanks, Fender. Oh boy. Okay. Jet fuel. How are his? There we go. He's got specs on it. Okay, so we're looking at a battery that is 6 inches long, 1.75 in width, and 1.25 in height. 486 grams. So let's draw that up real quick. I'm just going to take this battery and I will modify it to fit that and then save it under a new name. So let's compare this. We have, can't see my specs. There we go. Okay. 6 inches long. 6. And we are, looks like this is the short side on that pack. So 0.25 and 0.75. See if I move my balance leads over and move these in. Oh, we got too many balance leads. We don't need 7, we need 5, right? No, what are we doing? 4 cell? 3 cell? Oh, Fender, you sold me 4 cell. We're doing 8, huh? We're doing 8. Okay. In. Okay. Oh, it looks like their balance leads come out of the other side down here. And their battery leads are a little closer together.
Fender, it's only 300 something kV.
Yep, you're right. Okay, there we go. That looks like that battery. And let's see if I can change that color to be our light gray. And we'll save that as a new battery.
William Hoth, get the voltage up. 4 is good.
4 is good? Okay. What is this called? Jet fuel? Jet fuel 4S 5200. Save. Okay, so there's our new battery. Ooh, I want to check the weight. Pounds, grams. 216. And what did Stone Blue have theirs rated at? Way more than that. 486. 486. Alright, so I'm going to override this thing. 486. Okay, so now we should be calculating our weight properly because I've entered that right in. Now we can stick these packs right in the side of it. So, which way should they go in? Should they go in like this? Should we go in flat? Let's go in flat, right? Attach that there. And we're going to start locating this thing in here. I'm using a width mate in order to center it up inside of this pocket here. Go. And then I'm going to take the bottom and put the bottom, I'm going to use gravity. And, oh, I can't make those coincident because there's draft on there. But I can use that radius. for tangency. There we go. Okay, so now our battery kind of, ooh, that part's not fixed. Floating. Got a floating part here. Lock this in place before it goes anywhere. Okay. I'm just attaching all the planes together. And now that's fixed. Can't go anywhere. Okay, so there's our battery. And we basically kind of make that flush with the outside body. And then I'm thinking I add additional draft. No, not to that. To our body. So I pull up draft, and I just want to draft that face at like a crazy 60-degree angle or something like that. Yep. And so that'll be nice and smooth for our battery wires, right? So we got a cool pocket like that. Our battery wires will be able to come around the corner and plug right in. And we'll need the same thing on the other side, so we can mirror that. But before we mirror it, I just drew this thing all willy-nilly. Let's kind of lock this sketch up. That battery is going to represent like a significant amount of weight for this machine. So if we get the battery at the center point, we should have a fairly low a fairly low moment of inertia, right, in all our axes, because all our weight concentrated at the center of the machine. Throw some dimensions on this thing. Looks like my eyeball dimensions were pretty close to the real thing. And somewhere we've got a line we can attach to. Yeah, that's what I want to attach to. I just want to make sure I'm parallel to the body. There we go. All the lines turn black. That means I'm fully defined. And now I'm okay to mirror this thing. Mirror this across the right plane. Take that and the draft. Mirror them. It is on the other side. There. Pretty cool. Let's mirror the battery over there. Let's see. We're grabbing our right plane and picking the battery. Yep, that looks good. Okay, I'm gonna pull our live stream quad out of this assembly. Oh, because I kind of want to look at the weight of our base component so far. So evaluate the weight. Don't want the weight of the whole entire thing because these are solid objects. But I want to know what the total weight of the batteries and all of our motors are. So we're at like 1.4 kilograms worth of stuff just with our batteries and our motors. Not too shabby. Let's draw this multi-star motor up real quick because I don't have it. Right now I dropped in these T-motor motors that are like $200 a motor. So let's replace them. Proper thing here. I'm gonna make a new part, and since I have one right here, we can just pull measurements right off of it. let's see how I want to start. First thing, I'm kind of planning out in my head where I want to start this. And I think I'm going to start this as a revolve. Now, there really is no wrong way of doing it. There's what works for you, and there's what's faster for you, and what's faster for you might not be faster for other people. What's nice is to kind of plan ahead so that, like you saw with the with that battery, I quickly took a 6-cell 5000 battery and turned it into a 4000 or a 4-cell battery just by changing a couple dimensions, and it worked. And that's because the way I drew it allowed me to change those dimensions really quick, and the model didn't fall apart. You could see that I was able to drag the wires around and stuff like that. So that comes with just kind of planning out your build, and I think I'm going to plan to do this as a revolve on my front plane. So I'm going to insert a revolve feature, and I'm going to draw a center line from the origin. I'm wondering where I appear to have hit a key on the keyboard and turned snapping off. Where's snapping? Oh, filters. That key. Okay. How do I turn snapping back on? Automatic relationships. Ah, there. Okay. Oh, much better. Okay. Oh, I need to change my units over to millimeters because this is a metric thing. Millimeters. Okay. Make things easier. So I'm looking at how this thing's constructed really quick, and what's the best way to draw this guy up. I'm just eyeballing like that. And it has like a curved bottom and up, over, like that. Okay, so I'm not putting all the chamfers in there and all the fillets in there. That can come later on down in the chain. This will just give me a start. Okay, so let's take a measurement with the calipers here. 32. Okay, that exploded my drawing. And what's our diameter? 45. Start to straighten these out a little bit. Oh, that one doesn't straighten out. Okay, anyways. We keep adding dimensions. This will get better. Okay, that little top feature there. That's going to come in at like 19.5. And this thing here, these measurements don't look Lone Star because they're they are not proper by any stretch of the imagination here, you machinists. But there's fillets and stuff on here that I can't measure. So we're going to do our best. We just need a representation of this thing in the model, so I don't think anyone's going to complain. Like 5, 5. And I could probably get the calipers from here to here. Six. And she's locked in. Okay, so now let's revolve that. Okay, there's the base of our motor. My next step is going to be to hollow this thing out. So I'm going to look at it as a wireframe. And I'm going to do a revolve again. This time it'll be as a cut.
Cram Nitram waving hand sign.
Marty! Good to see ya. Okay. I'm also going to make this operation my cut that's going to separate the bell housing from the base. And I'm being pretty loose with this because I can't get inside of there without taking this thing apart. But that's about what that looks like. And the things that I can measure are that. About 6. And that gap is about 1. Thickness of this here is about 2.5. Oh, I got a little stray line right there. To make sure that this line is coincident with that origin there, because that's going to be revolve. I'm going to make sure that these are parallel. And this looks like that. That'll work. Let's revolve this cut, and I should be left with 2 bodies now. Our top and our bottom. Right, so if I do a cross section, there's our motor. Okay, and then these last operations are really gonna sell the look here. The bottom, and we gotta throw some cuts in here. There. Measurement for that. It's like 18.9. And let's see. Kind of want to do a pattern here. So I'm just going to draw a quarter of the cuts, and the rest will be just a pattern from that. So I've got this, and make this a 45-degree angle here. I have some sort of feature here. Comes in from the edge. And I need a better mouse on this computer. I can mirror that. that. Looks like this last path was something like this. Done. Make this a construction line now. And, oh, whoa, whoa, whoa. We're getting into the eyeballing here. I'm gonna say that it looks something like that. And then they kind of just went out from there. And I'll mirror that. And now we can start doing some cutting. Cut, cut, cut. That away, cut that. Okay, I should be left with my cuts. Yep, okay, and those cuts go up to that line there. Vertex from that thing. Got my order operations wrong. See a little problem here. Have to be. Yeah. Okay. So before I do this, I need to put the chamfer on that edge. They've got a chamfer here and a chamfer here, and that default value actually looks pretty good. Now I can do that cut. Yes, that's more like what that motor looks like. Okay. And now we can do our circular pattern. Take this thing, and round we go. 4 of them. Go, there's the bottom of our motor. Okay. Got a bearing here. So let me draw this circle real quick. That's 13 stuck in there. We'll extrude that just through the bottom. That's where our bearing sits. And then we'll do our top features like that. Right. Goofy looking thing. Again, it's like they took and no, that's not even like a slot. That's something else that they did. Some sort of like arc. And another arc out to the edge of the motor, like that. Yeah, they did something goofy like that. Okay, so that thing, measure that. 19. Am I doing radius? Yeah, so 19 divided by 2. And eyeballs are probably good enough. I can measure that. That's about 12.3. Yeah, see, the eyeball's pretty good. That's kind of like what we're looking at there. Then we just have these corners need to be filleted or whatever size cutter they used. Take a guess at what that could be. Yeah, that's about right. Okay, that'll be the one. And then there's that corner piece where we come in, go back out. And that sits at a 45-degree angle because, yep, there's 4 of them. This, and this are symmetric. And we can measure that as well. Yes, 10.3-ish. Visually, am I all right? Something like that. Trimming and cut. Cut goes down to about there. Ooh, again, order of operations here. Bad. We need to put that fillet on here at the same time. Well, so let me back that up and get this edge fillet on there. And there's only one of them. And it's about 2 millimeters. Let's roll that forwards. 7. Seven-ish. I can't get the calipers on there. We'll call it 7.5. Close to what we got. Same thing again. Circular pattern. Around the motor. There we go. And then we've got a couple holes to punch in the top. This one is for our shaft. It's like a 5mm thing coming through there, and then for some reason they ground it down after it comes through to ground it down to 3. We gotta put our hole pattern in. That's looking to be about an M3. And our position looks like it is a circular pattern here. Yeah, I don't. No, let's. Do that. Circular pattern. Yep. Good. And what do you think our hole to hole is? Is it 12? Yeah, I would say it's 12. Unless they did something really dumb. Like made it 11.8. I don't think that's the case. Okay, there's that. And there's a hole pattern on the bottom. And I'm putting these features in not because I like to waste time, but these will be important when we go to make the arms and stuff like that, that we have the right bolt pattern drawn on here when we go to make our clearance holes in our arms. That's going to be about 25. These are bound to be. This is not a circular pattern. They're not the same. Make sure they're correct angle here. 5. And we could just use a mirror operation and get them on the other side. Now, these two appear to be about 25 apart from each other. Which means that I drew that a little sloppy. These two, let's see where they're at. Looking like 19. I feel like I should check to see if there is a drawing for that. Because I'm not sure that I got that dead nuts. Do you think Hobby King was nice enough to give us that whole pattern? 19 by 25. You got it right. Okay. Just wanted to double check my work there. Those are good, but it definitely doesn't look like that. So I need to like back this off a little. There we go. Okay. Yeah, that looks a little bit better. There's definitely a little bit more meat around those things like that. Okay. Save that. This is going to be under my motors folder. Multi-star 14. And this is going to be -1 because this is going to be the first part out of 2 parts. Because this is just the aluminum, right? And next I'm just going to draw the steel. So I'm going to file, make assembly from part. Okay, there's my aluminum parts, and I'm going to tell it such that that is aluminum. And then I'll insert a new part in here. This part is going to be the metal that's in here. Okay, that's going to be revolve. Okay. I just have to make this thing fit. So that's like our bearing is right there. Our shaft comes out right there. Okay, there. This part, we're going to tell it that that part is that's going to be steel. I have a magnet here. Let's just say plain carbon steel. Okay, now I can open this part up and throw the dimensions on there real quick. Measured this as being 13 millimeters divided by 2. This, I believe, is 2.5 millimeters. This is measuring big. It's not 3. It seems to be 3.1. 3.1 meters. And it's our height. That height is good there. Height from here to here. That's the 3mm shaft sticking out. That's about 9.5. Not 9.5 inches. 9.5 millimeters. There we go. Now, the second thing I'm going to do here is to put a weight in here to represent the windings. And so I'm going to do another sketch on my front plane here. And this will kind of give me my final motor weight. I'll just tune the dimensions of this thing in order to give myself the correct weight, and then the weight should be distributed properly as well. Okay, so let's say like that's our windings. Back to the motor. And I can just kind of eyeball this thing up. Our windings start just below the surface there. And they come out about flush with the bottom of the bell housing. And I need to make that thing smaller in diameter as well. Okay. Okay, now I can save this guy as our multi-star motor. Change our units over to grams and stuff. And take a look at the weight. I drew it as 139 grams. And my scale says it's 159. I would imagine these wires probably are the difference. It's kind of showing around 16 grams of wire, roughly. So, what did I say? 159? 59. Yeah, there's probably about 20 grams of wire sitting there. So, I'll bring the weight up just a touch. And so, because I kind of drew that part in there, I just edit that, and I can kind of make that little guy just a touch bigger. And then take a look at the weight. 149, then figure 10 grams for wire. I think that'd be good. Save that. And then we can throw this in our assembly here. Okay, so now we're going to replace our U3 T motors with our multi-star quality Hobby King motors. Okay. Locate these things. Okay, and then our mirror and mirror it across there. Go into our other mirror that does the front to the back and mirror there. Go, and then we can delete that original T motor. Cool. Now we got the proper motors in there. Nice. Save that down. Where'd my little clippy board go? Go. Seeing my little buttons there. Awesome. Cool. What are we at? Oh, 11 o'clock already. Went by fast. Went by fast for me. Of course, I'm doing the work, guys. Where's chat? Yeah. So that was like not chat involved because I'm just doing motors and nonsense. But let's get the chat back into this. Where am I putting my motor arms? My vote is straight across right here. And straight across right here. Right? Form an H. Rather than doing an X with them. I think it's going to be easier to fabricate this thing if we do it that way versus trying to form an X with this body. But I don't know. Let me think. Let me know what you guys think about where we should go with that. This body should be
Quest_FPV square.
Square tubes, or are you saying do a rectangle? Run the arms around that rectangle.
Quest_FPV yet.
Right, that'll give us support on 2 points for the ducts. Okay, what are we using for material for these things? Oh, what kind of tube is there? Maybe a machined motor mount that connects to a round carbon fiber tube. They don't have any airfoil shaped carbon fiber tubes, do they?
William
that don't
Hoth,
cost an arm and a leg. Guess let's start drawing our first one. Two part. Open this part. Draw our tube. And I don't know, I'm just gonna throw a value in there of like, how big is this? 1.5 inch tube.
William Hoth use helicopter blades.
Helicopter blades. Well, that's an interesting idea. That's causing me to pause. Interesting. Are they straight? Is it a straight airfoil or do they like change from like root to tip?
William Hoth straight.
Straight. Alright, that's not that is a cool idea. And they're probably what? Carbon fiber with like a balsa core or something like that? Don't know much about the helicopter world. But that sounds like a good idea. If they're thin and we form a rectangle with them, with heli blades, that should be a pretty rigid setup. And they're thin enough
William
that
Hoth
making a
carbon
motor
foam.
mount carbon foam. Anybody have any dimensions for heli blade?
Quest_FPV I like that.
That's yeah, that seems like a really legit idea. plane. Just drop that there and start a new part. Same deal. Let's sketch this out. And this would be an airfoil, right? I can't picture what the airfoil looks like. The leading edge sharp? Or do we have something more like just like a football?
William Hoth 1/4 thank X 1.75.
Making it too easy on me here. Something like that. There. Hide this for now. This appears to be a better idea. I gotta hide that sketch. I keep touching it.
William Hoth just happened to have one on my desk.
Oh, yeah. How convenient. How lucky for us that we can lay this out like that. We did something like that. And then made a motor mount that we could just put, 2 screws there, 2 screws from the other side. Probably rigid enough, right? Let's draw that motor mount up.
William Hoth Wolf has many to donate.
Well, if we can get 2 of these beasts up in the air, have a little heads up race, I'll be happy. Wait. Okay, so we got a little like turn part here. Millimeters. Because we've got like our. This guy's got to mate up with the motor. Motor is 19 by 25. Size our part here. 5 millimeter. Place to start. Okay, I'm gonna extrude it in that direction, and we're gonna go like that 1.75 inches. The part we start with. And then from the front, we can machine some material away. Cutter coming in like that. Mirror that. Say that this guy's. Oh, not straight. Not straight. Vertical slots here. 10 millimeters there. 5 there. Sure. I don't know. That's just going to be whatever. Something like that. Okay, those go through the whole thing. Then we come in from the right side. Do another little operation here. Same kind of deal. I think I'm going to cheat and just make that face straight. So that face would look something like that. And then the other face will look yep. Alright, so this is what I'm thinking for a motor mount. And on that face, we give ourselves our M5s. That. This face, we put our M3 motor mounts in. Clearance hole, not tapped hole. If I bring up that original sketch that I drew in, I can attach my points right to it. There. I see I have to do something. I have to turn this thing 45 degrees. Like that. These should always be perpendicular. And let's put them at a 45-degree angle. Okay, now I should be able to come in and put screws in. Somewhat. We need some clearance holes for the heads of those screws. These are all equal. These are all like 6.5. And we're just going to do an offset. And the offset will be how much material I want to grab onto. 4 millimeters of material should be plenty. All right. Here's our motor mount. I need clearance for the bearing. And that bearing was about 13 millimeters. And we can... that's going to be ugly, so I'm going to go 2 millimeters deep. And then I'll put a smaller hole through the whole thing. Just to stay away from those counter bores. So like 6 millimeter through the whole thing. Gotta make this thing nice and light.
Quest
6, 8.
_FPV add another side bracket for the other arm going back to front.
Oh, Quest, you got me. You're right. Very silly of me to. I got ahead. I got ahead of myself. Ruined my fun. It was so going so well. She is. So, little motor mount like that going, huh? Yeah. Boy, that could work, huh? Now that my fun's been ruined and I'm gonna have to draw this thing from scratch again here. We gotta put that second one in there. Best way to do this. Delete that. And let's make it 2.
Quest _FPV sorry wasn't paying attention I'm printing
Haha.
and listening.
Okay. I'm gonna do one side through. And then I'm gonna do the other side differently. Right? So that. Right? I think this will get us to the same spot. Now I have to modify this. It's got sharp edges and stuff. Crazy about the sharp edges. Picture in my head how to make this thing. That's what's kind of giving me a little pause here. 5, that's 10. Side. Have cutter to come through. That's not as pretty anymore. This is super sharp right there. Kind of what we need though. Get rid of these errors. And we need some on this side as well. Bigger fives. Ooh, that looks really big. Oh, clearance hole. That's why it looked so big. That's not my tap tool. Okay, that's better. Okay, back over there. Well, there would be our corner. Then that would butt up against there, and then we drill. I don't like the idea of drilling the holes. That makes that too weak. Maybe it should be some sort of pinching thing. But the idea is there. The idea is there. It's going to be a longer blade to go front to back, though. Certain distance here. Making that one independent so we can set it to a different length. Front plane should be able to coincide. Make that a little longer. Okay. And this guy needs to be a little shorter. A lot shorter. Yeah. Huh. We'll work on this little part here, and we got kind of a solid idea here. I think it's kind of ugly. The way I'm connecting these, it's just the first thing that popped into my head. You know, throwing screws through them. Well, it certainly builds fast that way, but it's not quite as pretty as I would like it to be. I almost would like to have a cone behind the motor. That would be, it would be pretty looking. How do I hollow that out to make that work? I don't know. Save that for another day. Anyways, let's get these motor blades here. That to the mirror and that to the mirror. Blades. We can add motor mount to the mirror. Right.
Quest_FPV. How hard would a sleeve that they fit into be to make?
Right? Wouldn't that be much better looking? Right? If you slide that into a sleeve and then and then pin them, pinch them real good. That would kind of distribute the force across the whole face of the blade rather than just on a washer, two washers or whatever. I'm thinking this is relatively easy to assemble, easy to build. Means a higher likelihood of it, getting done with our crazy schedules, but do I have a propeller I can throw in here?
William Hoth glue.
Glue them. Epoxy it right in there.
Fender, is there going to be some yaw flex there?
I've never handled one of these blades, so I don't know. I mean, yes. Is it going to be a controlled amount? Perhaps. I'm starting to picture a new mount here. Okay, so let's roll it back. All this. Gone. Okay. So if we turn that, then we slot the front.
Fender, it would depend on the buckling load running left to right. The forward and back ones will bend that way.
I think the only thing I would be afraid of is the yaw making the motor bounce, right? Under like hard braking. If the motor's gonna like bounce a little bit, because those are basically like two leaf springs when it yaws, right? And you get a little like bounciness, which make the PID go crazy. I don't know. Okay. So here we're proposing we slot this, right? And we're gonna go front like that. Don't want to touch tips. So and Then I'll rotate this around the body, but I'm only going to do 90 degrees to each other. Okay, so that's where we're going to epoxy the blades into. Then here, sheen away this. And leave ourselves a wall, 1.5 millimeter wall. Wall there. Here. Okay. That and that. Take it. That. Say that's 35. Yeah, let's put our like cutter in there. Leave me much room for a head of a screw right there. Well, that's the idea that popped into my head from that suggestion there. And let's say if this is being turned, we could also have some fun while we're at it. What can I flip the side? Oh, my revolve to go the other direction. This mouse is just the worst. Okay, so there's like our new motor mount. I'll save the detailing for later in case we change our mind again. Okay, so now we'll flip this guy around. And we're going to say that we're going to epoxy these things in there like that. I don't know. That's an idea as well. We're just full of ideas tonight. There. That is a better looking motor mount than the first one. That's for sure. Throw some epoxy in there, put a little screw through it for safety. Doesn't have to be a big screw. A little M3 through there. Much cleaner looking. Good suggestion. Good suggestions from the chat tonight.
Quest underscore FPV day AAAM.
Hmm. This thing would be pretty fun. Who wants to do some vacuum bagging? Make for a wonderful tutorial. Get some carbon fiber pre-preg and then get the old vacuum bags out. Let's do this. And get to work on cutting these molds. Cutting the plug or whatever we gotta do to make this thing happen. How do we intersect that with that? I'm gonna make a little 3D printed holder or something. Ooh. They're allowed to rotate. I like it. I like them pitched out like that. Now we just need a little connects piece to fit inside of there and hold those together. Kind of be built right into that part. That section. Let's up and take a look. So over here, something like that. Again, I'm trying to make a cut. I'm not cutting, I'm adding. There we go. That. Just sketching ideas here. We combine these two. Oh, lick. Oh, even that's too big. Why? That's that edge. That's alright. I slid it over just a touch. Would you let me do it then? Follow that edge around. Nope. Still no. Come on, SolidWorks. You know what I want to do there. Do it. see more stuff that's gonna be cool. Yep. We don't need that thing. That's not what we need. That's not what we need. We just need another thing across there. Thing across the thing. Spline tool out. See where I'm going with this. We use this to uh, 9.25. Okay. Yeah. So, oh, things are getting a bit funny on me. Anyways, that would be the connector between these two, and that would form one part. And that would be how you attach the helicopter blade there. Okay, these things are out of control right now. I need to lock them in. Top plane to top plane. Lock them in. Oh, that needs to be a distance. 20 millimeters ish. The other direction ish. That's not going to cover the blades. 40. That'll cover the blades. Okay. Right now we're under control. My mirror needs some modification. Will help. So we go to the orientation of this part. There we go. Okay. Sweet. So this would form one part.
William Hoth looking like
connected.
Something from Avatar.
Right? Little hover ship from Avatar. Yeah, that you're right on the nose. That's what we're building. The future is here, man. Oh, can we fix this mirror in the back too? Make that point the right way. For that matter, we could really do the same thing right there. Then do we need the helicopter blades? Yeah, we still need them. That's just going to be a method for attaching them. Yeah, you know what? I want to throw something in here. No, run cam. Come on. Oop. I just had to drop that in there. It's getting late and it's about the time to wrap up for tonight, but I figured just give myself a sense of scale right there. I gotta throw that on there. Oh yeah. That's fantastic. Maybe we put this more like on axis, like right there. That's too much. It's too cool. This thing's gonna have to have a little cutout, a little notch for a GoPro as well. You gotta stick a GoPro on this thing. Seems like a waste of a lot of real estate to not put a nice camera on there. That's not gonna slow you down on something like this. Well, I think this X class is coming along fantastic. Figure out just how we're gonna make these parts. Center body, I understand how to make that.
Cram nitram, it looks like a turret from Portal.
Portal turret? I'm not familiar with Portal. What's Portal? But you got any ideas of how we're gonna fabricate this guy? I mean, I picture myself cutting out a lot of foam, but then where do we go with it? Epoxy coat the foam and make a tool from it and make this all out of fiberglass? Like inside, an inside and an outside, two pieces. Then put them together and hide the seam. Or is that just going to be end up being ridiculously heavy? No one says that they have to be a nice three-dimensional form like this. I mean, we could just take carbon fiber and
Fender hot
bend it
wire cut
around.
foam, then laminate it.
Just laminate the foam. Yeah, I mean, I could get a nice 3D shape like this on the CNC, and then we can laminate it from there. I'd like them to have to be able to stop the blade. That's the only thing that concerns me. That there should be like a fiberglass ring or something in there, so that they have enough strength to actually like stop the blade if it hits something. But they're not just gonna fold up and then the blades are gonna go to town on whatever it is that it hit. Stretch that body just a little bit. It's gonna touch there, and we can merge this whole thing.
Fender or foam core with a balsa cover, then laminate.
Figure out how I drew this thing, so I can stretch this body back out. I want it to touch. Get it out. Oh, almost there. Almost. For some reason, I like it just to be a little bit minion shaped. Got contact. Now we can kind of turn this into one chunk. So right now in my head is I'm trying to picture just how to machine this
William
and
Hoff, I've
then lay it
molded a
up.
similar shroud for a duct fan. I think I still have the mold.
Yeah. Could you just get a ducted fan from a ventilation fan and use that as a mold? Then just kind of vacuum bag some fiberglass up against it? Is that a possibility? You have like a 16-inch ducted fan shroud or something like that that we could use. Oh, hello. Does that mean it's time to go? Yeah. Are you looking for somebody to lay down with? Yeah. All right. Pick this up tomorrow, or sorry, next week. Yeah. You're not gonna walk on my keyboard there, buddy. All right. I think we'll pick this up next week, and we'll discuss just how crazy this is gonna be at the safety meeting on Saturday. So, all right. Thanks everybody for sticking around with me. And I'll see you this weekend. All right. Have a good night.